Hello, Junior Design. Professor Dondelinger here. Welcome back for our week-long series on the power tools for DFMEA. So you've seen the first two videos at this point. Those were put together by some of my colleagues who I haven't met yet, but they did a great job of overlaying the basic process that's followed for design failure modes and effects analysis. I worked with that technique both in my job at Ford and at GM. And when I was there, I worked with folks that had the title of DFMEA Process Guardian. I'll go out on a limb to say, well, if I were the process guardian and people just did what they saw in this video, embraced it, and executed the way it was shown, I'd be pretty happy. They did a nice job of explaining it. What I want to do this week is cover a few techniques that, particularly when I was at GM working on design failure modes and effects analysis, I discovered a few areas of the process where there are some alternative techniques you can use that will take you down different lines of thinking about the design and help you think a lot more broadly, especially early on in the design, about what kind of failures you could identify and what you could do about them. That's what we'll be talking about. To begin, I wanted to show an overview of the form that's used for DFMEA, and these were covered in the videos, but at a very high level. Three sides of the form. On the left side, basic answer question that you're answering is what could go wrong? And you'll see that this is broken out in these fields, starting with the part in the system. So this is a part by part view of what's in the system you're studying. Once you get to that function or that part, you start articulating what functions that part performs. After that, you can look at the effects of a failure and what the causes of that failure would be in the design. And that's what's getting addressed in the left-hand side. Middle section of the form, addressing the question of how bad could it be? Because as you go through and identify failure modes in your design, some are more severe than others. It's important to make sure that the severe failures get addressed. Some of the less severe failures, it could be okay to leave those as issues that can be dealt with when the product is in service. So flipping back to the talk we did on the GM ignition switch, if the issue is a customer convenience issue, something the customer doesn't like, it causes an inconvenience, but it's not safety related, that would have a lower severity in the DFMEA. It doesn't necessarily need to be addressed. It's good if you can address it from a standpoint of doing well in the market and satisfying your customers. Whereas if it comes to light that the problem is safety related, then it must be addressed in the DFMEA. And finally, on the right-hand side of the form, this is where you're filling out what can be done about it. And you'll see that here there's not only a list of specific actions you can take to change the design, but also in this version of the form, there's tracking information so that you can determine not only what needs to be done, but who's doing it, when you think it's going to be done, and verifying that it actually has been done and you've reassessed the severity of a failure and it is now decreased. And so as you think about at what point is a DMA finished, it can be considered finished in some sense when you've worked through and gotten to the point that you've identified a remedial action for every possible failure mode, but it's really not done until you've taken all the required actions to make sure that you've actually changed the design. So in our lessons this week, what I'm going to cover are the 3 power tools for DFMEA, and that's my verbiage. The first one, all the way over on the left in the block that's pointing up to function, is modeling the function and the flow in the system before the form. So you can see in the original DFMEA form that we showed, the item all the way over on the left, the thing that is the first trigger to start your thinking about the design is what is the part? Then you describe the function. What I'm going to show you this week is that you get a different perspective if you start by identifying the function and then think about how the part performs that function. In many cases, for what we're talking about, you wouldn't even have to know what the part was before you could start identifying failure modes. And that gives you a lot of freedom to start designing out failure modes early in the design process. Second power tool is identifying failure modes with guide words. This will be covered in a later lecture. You'll recognize that slide again when you see it. The idea here is to use a structured set of words to think about how a function could fail. This is the technique when I talked earlier in the ignition switch series that I'd be borrowing some information from the book Nancy Levison's Engineering a Safer World, which I continue to plug. This technique for using guide words to identify failures is more commonly used in system safety studies. And so what I'm showing you here is that it is a great technique in that context, and it can also be quite helpful when you're performing a DFMEA. And finally, over in the center section, but it's the item here on the right, the RPN is the risk prioritization number. And this is a quantitative index. It is actually computed with numbers to give you an idea of the relative severity of the failure modes you find in your design. What I'm going to cover is generally recognized that the RPN does not have a purely absolute meaning, and we'll talk more about why that is later. The question then is, if the RPN doesn't have a purely absolute meaning, how do you use it? What I'm going to show is an approach that I believe is the most effective, which is, in place of the RPN, use the information you compute the RPN with, but then interpret it using a heat map, which is the glyph that I show in the bottom right. So that covers the material you're going to see this week. The remaining material in the first module will get you to the point that you understand what the flows are through your system, because that will dictate what the functions need to be. And then when it comes to the other two power tools, we will discuss those later this week in the second module. But that's what's coming. Next module, you'll see, we'll begin to talk about what it means to model function and flow before form. Thanks much. See you next time.